All right, guys. So what we're going to do is we're going to find zeros of a polynomial. Now, the last lesson that we did was synthetic division, and we're going to use the synthetic division to help us find zeros of a polynomial. Now, let me just start off by saying that typically what you could use to solve like this first problem, we want to find the zeros of this function. Well, what you could do is the rational zero theorem, which basically would give you options, the possibilities of any of these rational zeros. And then what you would do with those is you would test them. And then when you found out it was true, you could use synthetic division to help you find and confirm those zeros and then make your function smaller, a smaller degree so that you can find the rest of the solutions. Well, in essence, we're going to be doing the same thing. We're not going to use the rational zero theorem. We're going to graph the function, which is what I have right over here, is I have this function graphed already. And I have the zeros already highlighted. So you can see those are the zeros, which are the solutions. Now, based on the function itself, the highest degree is a 3, which means that there are 3 solutions. Now, you could have a combination of real and imaginary, knowing that imaginary solutions have to come in pairs. Well, clearly, since this crosses the x-axis 3 times, that means we have 3 real solutions. Well, we need to find the exact values for that. Obviously, these two right here, this and this one, they are irrational. And based on the way this is graphed, I know it's only going to 3 decimal points, and you say it's terminating, it actually is not. This point, the second one, 3, 0, is the actual only rational zero that we have. So what we're going to do is we're going to use that solution and use synthetic division to knock this function down, this cubic, to a squared. Because if I do synthetic division, which you have to do by something that's linear, it'll knock it down by 1 degree. So if I use this solution here, which is 3, 0, and I'm going to set it up, so I'm going to do my synthetic division. Remember, it's upside down house, coefficients. Now, I should get a 0 for a remainder because this is a solution. Remember, the number that goes out here is the solution. When we were doing synthetic division, you were dividing by a factor, which this factor would be x minus 3, but we always divide it by using synthetic division, which is the solution, which will be 3. So then I go ahead and drop this down, multiply, and that goes here, add down, multiply, add down, multiply, and you can see that I do get 0 for my remainder, which means that this is a factor, which means that this value here is a solution. So I definitely found one of the solutions. So what's left over is x squared minus 7x plus 2. Remember that we use the numbers here, what's left over, the coefficients for our function less 1 degree. So now you can check and see this is not factorable. The only way you can do this is the quadratic formula. So when we set up the quadratic formula, and just to write it one time, so you have negative b plus or minus square root b squared minus 4ac all over 2a. So when we set that up and solve, we're going to wind up with negative b, and b is already negative, plus or minus the square root, negative 7 squared, plus 4 times 1 times 2, all over 2a. And that's going to become 7 plus or minus square root, I guess I can add another step in here, 49 minus 8 over 2, which becomes 7 plus or minus the square root of 41 over 2. Now, if you were able to simplify this anymore, you would go ahead and do so, but the square root of 41, we can't simplify anymore, so that's pretty much it. So what that means is the solutions here, we have x is equal to, remember, we found the 3 here, so it's 3, and then these two solutions, so 7 plus the square root of 41 over 2, and 7 minus the square root of 41 over 2. That's where these values over here the decimal equivalents are right there. So this one would be that value here, and then this one would be that value here, if you were to get the decimal equivalent. But we want the exact answers, which is what we have right there. All right, let's look at another one. So here we have this function. Now I already put the graph, and then you're saying, oh, well, I have a 3 here, which means that I should have 3 solutions, but this only crosses right here at 3, 0. That's because the other 2 are going to be imaginary, which means that I should have I in my answer. So again, let's go ahead and set up our synthetic division. And we got a 3, negative 11, 12, and negative 18. So that should definitely be a 0 remainder. So drop this down, multiply, add, multiply, add, and then we get the 0. So then that's good, that's what we need. That leaves us with 3x squared minus 2x plus 6. Now you could try to factor that. It's not gonna work, and if it were factorable, then they would definitely cross on the x-axis because they would be our real solutions. So we're gonna go ahead and plug into our quadratic formula, and that's going to be negative 2 plus or minus the square root, negative 2 squared minus 4 times 6 all over 2a, which is this here. So that becomes 2 plus or minus the square root of 4 minus 72 over 6, which then becomes 2 plus or minus the square root negative 68 over 6. So now we can see that we have a negative inside the radical. That's definitely going to give us the I, but we also want to simplify the square root of 68 if we can do so as well. And that does, we'll bring this down a little bit here. So this becomes 2 plus or minus 2i square roots of 17 over 6. And we can still reduce more because all 3 of these numbers here are divisible by 2. So that becomes 1 plus or minus I square roots of 17 over 3. So these right here are the other 2 missing solutions. They're imaginary, which we talked about because they do not cross the x-axis. So we have x is equal to 3, and then we have 1 plus I square roots of 17 over 3, and 1 minus I square roots of 17 over 3. Those are our 3 solutions right there. All right, let's take a look at the last one. So now I got to the 4th power and I have this all graphed. And I just want to clarify that this is that solution. And then I'll pick the other so you can see, so you don't mix those up. Now we need, looking at the function, we have 4 solutions. Well, I need to, if I want to knock it down to a quadratic, which means that I can definitely use the quadratic formula, I need to find 2 rational. And you're going to see that that's here, negative 3, and that's this one here. 0.333 repeating is 1/3. So we're going to go ahead and do the synthetic division on those 2 values. Now watch how we set this up. So I'm going to just pick the negative 3. I'll do that first. And now your coefficients. So I have 3, 23, 43. I got 1 and negative 6. Now I should definitely get a 0. So I drop down to 3. It's negative 9. And this is going to be 14, which would be negative 42 when you multiply. Add down is 1. That's negative 3. That's negative 2 when you add down. Multiply is positive 6. So I get the 0. Now, stop right there. Don't write this with the less 1 degree because we still want to check this value right here, the 1/3. So I'm going to actually just drop down another division house, upside down division house, and do the 1/3 right from here. Don't go back to the original. If you go back to the original, you're going back to the 4th power, and you're just going to knock it down to the 3rd. So right now, this is x to the 4th. This is now x to the 3rd. And when we do this division, it's going to be x squared. So you just do it right from there. So I'm going to drop down to 3. Multiply is 1. Add is 15. Multiply is 5. Add is 6. Multiply is 2. And look, I get to 0. So then the question is, if you reverse these two, like if you did the 1/3 first, would that work? And then the -3 second? Of course it would. It would definitely work. So now I have 3x squared plus 15x plus 6. And when you get that, you can do the quadratic formula, but I can just make this smaller. Obviously, you can set that equal to 0. I'm just going to divide everything by 3 just to make the number smaller. So that's going to give me x squared plus 5x plus 2 is equal to 0. So just when you're working with the quadratic formula, it makes the number smaller, a little bit easier. So we're going to go ahead and set this up. So that's going to be negative b, so negative 5 plus or minus the square root of 5 squared is 4 times a times c all over 2a. And that's going to become negative 5 plus or minus the square root of 25 minus 8 all over 2, which becomes negative 5 plus or minus square root of 17 over 2. And of course, we cannot simplify the square root of 17. That's already done. So these two are for that solution, and it is for this solution that you see there, the two irrational ones. So overall, we have x is equal to -3 and 1/3. We already checked those earlier. And then what we got with the quadratic formula, so -5 plus the square root of 17 over 2, and -5 minus the square root of 17 over 2. And that is it. So hopefully this helps you with finding the zeros. And I will definitely see you on the next video.